Hi, this is just a review again of how to solve rational equations. Again, rational equations are equations that have fractions in them. Rational is just another way of saying fraction, or sort of the algebra 2 way of saying fraction. So what we do in almost all the problems, and the method that will always work, is you can get a common denominator. So in example 1, you see that a common denominator could be 4x. So what we're going to do is we're going to rewrite this so that it has a common denominator of 4x. So it means you're going to have to multiply both the top and the bottom by 4. So we're going to get 8 over 4x. The second fraction, we'll have to multiply both by x. So we will get 1x over 4x. And the last equation we'll have to again multiply by 4, so we will get 4 over 4x. What's really nice once you have all common denominators is what you're really doing is you're multiplying both sides by that common denominator. And if you multiply your entire fraction by 4x, what happens is as you distribute to each individual fractions, the 4x cancels out, and you're just left with 8 plus x equals 4. And then all you have to do now is solve for x. So if I subtract 8, x equals negative 4. Now, things that we have to be aware of when we're solving rational equations is we have to be aware of values that don't work. So looking at our original equation, there's an x in the denominator, which means x could never be 0. Well, it's a good thing we didn't solve for x being 0 because we can't divide by 0. We got x equals negative 4. Now you should check your work every time you do this. So if I plug that back in and if I check, I use a different color, this would be 2 over negative 4 plus 1/4. And it's supposed to equal, positive 1 over negative 4. And if you had a half, or if you add this together, those two things would equal, and check, this is your solution. So in every problem, if you get a common denominator, you are able to solve. So let's look at example 2. Let me go back to a different color. We need to have a common denominator. And if we're going to get a common denominator, that means this first fraction needs to have an x minus 2 to both the top and the bottom. That means our second fraction needs to have an x plus 2 multiplied to the top and to the bottom. And the same thing is true for 0, but anything times 0 is 0. And so just like we did in the first fraction, if you multiply this whole thing by the common denominator, they're going to cancel out. So you're just going to be left with 3 times x minus 2 minus 1 times x plus 2 equals 0. And so now you just distribute and solve. So I would have 3x minus 6 minus x minus 2 equals 0. Combine like terms. So I have 2x minus 8 equals 0. Add 8. So x in this case equals positive 4. Again, as we look back at the beginning, x cannot be negative 2 because that would cause us to divide by 0, and x cannot be positive 2 because that would have us divide by 0 in this fraction. So 4 should work. This would be 3 over 6, which is a half, minus 1 over 2, which is a half. So 1/2 minus 1/2 is 4. Check, that is a solution. So in all of these problems, we're trying to get a common denominator. Let's do one more example. Again, in my last example, I want to have a common denominator. So the first fraction needs an x plus 2 multiplied to both the top and the bottom. The second fraction just needs an x multiplied by the top and by the bottom. And the third one, even though we don't think of this as a fraction, it is, we have to multiply both the top and the bottom by x and x plus 2. Again, once you have a common denominator and you're solving, what you're doing is you're multiplying by that common denominator so that it cancels. And so when it cancels, what happens is you're just left with x plus 2 plus 2x equals x times x plus 2. You're just left with what's in the numerator. And then all you're going to do is continue to solve for x. So I have a total of 3 x's, it looks like, on this side, plus 2 equals x squared plus 2x. I now notice I have a quadratic, so I'm going to put all of my x values to one side. So I'm going to subtract 3x and get a negative x, subtract 2, which means this side would be 0. And again, when I get a quadratic, I'm going to try to factor. So I'm going to get a minus 2 and an x, what is that, plus 1. So x could equal 2 and x could equal negative 1. And I want to make sure, before I say my solutions, I want to check. So looking back at the original, x cannot be 0, because that would cause me to divide by 0, and x cannot be negative 2. Cannot be negative 2. So I'm going to plug those back in. If I plug in 2 to this first one, that would be 1/2 plus 2 over 4, and that would be 1/2 plus 1/2, which is 1. So this is a solution. If I plug in negative 1, this would be negative 1 plus, if I plug in negative 1 on the bottom, that would be 2 over 1, and negative 1 plus 2 is 1, and therefore both of those are solutions. So that is just, again, a quick review of how to solve some rational expressions. Sometimes you will have to factor, but you do always want to check your work as you go through.